A valve that looks perfect on a spec sheet can easily cause a system shutdown if it fails under real-world operating pressures. If you are sourcing industrial components globally, relying solely on a pipe size and a flange standard leaves your facility vulnerable. You need a reliable manufacturer who actually understands the operational demands of your system. To prevent these failures, we are going to build a complete technical specification step by step. We will match the correct body materials to your specific fluid, balance your pressure limits, and optimize the valve design to fit your maintenance routine. But a perfect technical specification requires a capable partner to execute it. So the final step is running through a precise vetting checklist to ensure you select a trusted, high-quality international manufacturer. Step 1 begins right at the source. Before we look at valve mechanics, we have to analyze the specific fluid traveling through your pipeline. The chemistry of your media strictly dictates your seat and body material choices. Mismatching these elements leads to rapid corrosion, degradation, and eventual system failure. This chart shows how standard utility applications map directly to common materials. Basic water and HVAC systems safely utilize cost-effective cast iron bodies paired with EPDM rubber seats. As the chart expands to include harsh environments, the material requirements change. Mining slurries and corrosive chemicals require you to specify PTFE liners, Viton seals, or highly durable duplex steel discs to survive the flow. Using basic elastomers for these aggressive surfaces creates what engineers call the cheap seat trap. Saving money on standard rubber for chemical lines is the primary cause of premature pipeline leakage. Now that we have matched the materials to your fluid, we need to handle the physical forces inside the pipe. The next variables to define are maximum pressure and temperature. This diagram shows the mechanics of a quarter-turn butterfly valve. The central disc rotates 90 degrees to control the fluid. Because that disc stays inside the flow path even when fully open, it inherently creates turbulence and a slight pressure drop. Looking closer at the central axis reveals the concentric design. The stem and disc are perfectly centered, compressing equally against a soft, resilient seat. This configuration works well for standard utility and low-pressure water systems. When system pressure and temperature exceed utility limits, you need the devil offset design. Notice how the axis line shifts away from the center. This adjusted geometry reduces friction on the seat as the disc rotates, extending the valve's lifespan under higher pressures. For critical infrastructure or extremely high-temperature service, the diagram introduces a third angle offset. This triple offset design replaces the soft rubber entirely with a precise metal-to-metal interface to achieve zero friction sealing. Keep in mind, if your specific piping system strictly requires absolutely tight shutoff combined with zero pressure drop, a butterfly valve will not fit the requirements. You must specify a ball valve instead. Specifying a basic concentric valve for a high-pressure application guarantees heavy, continuous friction. The soft seat will tear, leading directly to costly operational downtime. Step 3 moves our focus from internal pressure to your facility's operational requirements. The structural choice between wafer and lug connection styles depends entirely on your maintenance protocols. The left side of this diagram shows a compact wafer valve. It sits clamped tightly between two standard pipe flanges. Because it is sandwiched in place, it is lightweight and cost-effective, making it ideal for permanently assembled pipelines. The right side shows a lug valve. It is bolted independently to the pipe flange. This structural independence allows technicians to completely remove one side of the pipeline for maintenance, while the valve securely holds back the flow. Prioritizing the cheaper wafer valve creates a severe operational bottleneck if your maintenance crew actually requires end-of-line isolation. You will not be able to detach downstream pipes without draining the entire system first. Your facility's routine inspection and isolation requirements dictate the connection style. Verify this with your maintenance team to finalize this part of the specification. Now that your engineering specification is locked in, we move to international procurement. Vetting a valve manufacturer in China requires looking past the marketing. Look at step 1 on this evaluation checklist. You must demand verified pressure and life cycle test reports. Confirming actual manufacturing capability means moving beyond basic price lists and requiring documented proof of performance. A high-value supplier acts as an engineering partner. They will confidently recommend specific seating materials based on your fluid media and provide accurate actuation torque data for your automated systems. From there, confirm compliance with API, CE, or RoS certifications. Once quality is assured, verify their logistics for DDP shipping and strong global export capabilities. Prioritizing technical support and clear communication secures maximum lifecycle value for your international procurement. You now possess a complete lifecycle-ready technical specification. Your materials are mapped correctly to your fluid, the geometric offset balances your pressure limits, and the connection style accommodates your facility's maintenance schedule. To keep these exact specifications on hand, click the link in the video description to download the 2026 Butterfly Valve Selection Guide. This gives you immediate access to full technical specs and detailed material compatibility charts. With your specifications dialed in, you are ready to confidently request a precise quote from a vetted Chinese manufacturer today.